Indian landmass. And in January, it is in the opposite direction. That is northeast direction. These winds are coming from Siberian high and coming to the Indian landmass. Generally, if you can see, summer monsoon is we can have the wet climate, and winter monsoon is dry conditions. Generally, if you can feel this December to February, the entire India is, you can see that dry conditions. So if you can see the rainfall pattern, Indian rainfall pattern, monthly rainfall pattern, you can see June, July, August, September is the maximum rainfall month as compared to January and other regions. Okay, when the monsoon starts from June, the rainfall, the onset of monsoon is occurring in Kerala coast. Then it will spread entire Indian region. So the different stakeholders like agriculture for the farmers, irrigation department, and other electricity, and all other departments, based on the monsoon forecast, they can take necessary. Example, farmers, if the monsoon is below normal, then they can change the crop in the agriculture, in the cropping pattern. Similarly, water management and reservoirs, everything, it will depend on the monsoon rainfall. So that's what it is very important for the summer monsoon rainfall as compared to northeast monsoon or winter monsoon. So, in the more general definition, is commonly used is as we discussed, the wind is must be reversed in direction between summer and winter. Summer season is very wet, where we can see the rainfall is the maximum rainfall. So the Indian landmass is wet entire season, whereas winter is very dry. So if you can see these definitions, apart from South Asia, there are other part of the world which is also experience of monsoons. For example, the Southwest US, Northern Mexico, Western Africa, Australia, they are also having some sort of monsoons. Okay, so with these definitions, half of the tropics, if you can see the tropics, that is 30 degrees south to 30 degrees north, you can say it is a tropical region. So if you can see, this is one of the schematic picture of the winds at 925 hectopascal. Basically, during the monsoon season, the low-level winds, that is 1 kilometer to 1.5 kilometers, that is 925 to 900 to 850 hectopascal in the pressure level. You can see there is a clear changes in the wind direction. This is one of the analysis data. You can see the top panel is December, January, February, and the bottom is June, July, August, which represents the summer monsoon. You can see there is a strong cross-equatorial flow, is a wind flow, which is coming from southwest directions, whereas in the winter it is coming from northeast direction. So this is all like South Asian monsoon too. Okay, and also similarly the Australian monsoon, West African monsoon, and North American monsoon. So these are the monsoon occurring regions. So what are the major driving mechanisms? You know that land and sea breeze. Have you maybe in the school days we have studied land breeze and sea breeze. Majorly, this monsoon is also a replicate of this land breeze and sea breeze. So these two land breeze and sea breeze circulations develops because of differential heating between land and. So generally, you know that sea is having a greater capacity, greater heat capacity than land. Okay, that is land absorbs and emits the radiation more efficiently and faster as compared to sea. Okay, if you can see the data, the diurnal, the temperature, if you can see, land gets more quickly, it will heat as compared to sea. So once the land is heat up, then the air is expands more rapidly over the ocean and resulting between these pressure gradient between ocean and land. Because of this pressure gradient, generally you know that the air is moving from high pressure to low pressure. Okay, so when there is a more heat in the land, then the air is get moving upwards. Then because of the low pressure here in the land, and the circulations move from sea to land, then it will complete the circulation. That is, a warm air rises over land during the day, and cool air flows from sea. So these circulations we can have this land sea breeze because the winds are coming from sea. Similarly, land breeze during the night time. So ocean is having more absorption capacity than land. So in the daytime, it will absorb the heat and it will remain in the warmth in the ocean, whereas in the land, it will get quickly, it will cool. Okay, so then the rising motion will be in the ocean part and the sinking motion will be in the land regions. So then there is a cyclonic process. So these are the major mechanisms for driving the monsoons, not only for the differential heating, but also it will include the moist processes. So this is the, as a nutshell, here we are mentioning here differential heating of the land and ocean, because as this heat capacity is even larger, because the ocean is much larger as compared to land, and also in the land only upper part of a few centimeters will be heated, because due to the slow molecular transfer of heat vertically, the land gets heated only in the very shallow part. Whereas in the water, because of the turbulent mixing, okay, the heat is effectively mixed and it will store maximum heat in the ocean. Okay, this difference in the heat, okay, so which is more important. In addition to that, moist soil. While we are talking about this land, there is a moist soil. It is also behave like a ocean. Okay, it is also having this water vapor evaporation of the water vapor into the atmosphere. Okay, so this differential heating sets the pressure gradient in the horizontal. Okay, when it is a horizontal pressure gradient is there, then generally the circulation moves from high pressure to low pressure. Okay. Then what is the role of moist processing? Okay, so moisture acts as the source of energy. Okay, which comes from the latent heat release. Okay. So this evaporation occurs over the ocean, and this moisture transport over the land, and it releases through the condensation and gets rainfall. Okay. So these are the two major mechanisms for the occurring of monsoons. Okay, this is again so it is mainly this how this monsoon variability occurs with the monsoon region. So then comes to the what is the semi-permanent systems of the summer monsoon. So we are discussing mainly summer monsoon region, because we focus more summer monsoon, as the importance is more rainfall is more than 75% of rainfall occurs if you come to the total annual rainfall. So during the monsoon seasons, there are a few systems. It is not permanent system, but it is semi-permanent. During the summer monsoons, these systems will appear throughout the season, and once the season is over, then these systems will, as mentioned, that during the month of April and May, what happened? There is a high temperature over the Pakistan and Northwest Indian region. Okay, so when there is a more warmer over this land part, then what happens? There is a low pressure seasons occur, right? So then comes to the southern part of India, southern part of Indian Ocean. That is a Mescaline region. There is a high pressure zones is formed. Okay. So generally during this monsoons, this is the circulation patterns you can see in the trade winds. Okay. So in the southern hemisphere, the winds are blowing from southeast, and the northern hemispheres it will move from northeast. Okay, so these directions it will move from here. It will come from this direction, and the south it will come from the southern hemisphere direction. Once these winds are because here this high pressure and the land it is a low pressure regions are there. So the winds are blowing from southern hemisphere to northern hemisphere. Okay, so on the process of this is a high pressure belt. It will form, and it is a pressure belt. Okay, so this belt will extend from. So then here these regions, there is a dotted line is there. This region we can form as a trough line. That we can, since it is forming the monsoon season, we can call it as monsoon trough. Okay, and also western part of India, there is a, because of this high mountain regions, there is a vortex formation will be there in the western part. This is called, we can call onset vortex. So these are for the Indian summer monsoon. So if this is again, this is the observation data for the month of July. You can see here, right? Why it is Mescaline high? Because the high pressure forms over the Mescaline region. Then heat low. So current system, you can see the trough line, it forms over the head. Okay, so these are the major subsystems, and this trough line, whatever we are talking about, this monsoon trough, which is having a major rainfall, major rainfall variability over the Indian region. So this is the in general normal positions when the monsoon is normal condition. The monsoon trough lies in the these positions in the northeast part of India, and it will extend from Pakistan to up to head Bay of Bengal. Okay, so this monsoon trough is also a low pressure area. Generally forms in the northern plains during the summer seasons. So with this normal position, there is a normal rainfall over this northern central part of India, and also this western part of Indian region. Okay, so during this when this trough is not in the constant period, because there is when I say the trade winds from northern hemisphere comes from northeast direction, and the southern hemisphere it comes from southeast direction. It will form a thin line where it will coincide southern hemisphere trade winds and southern hemisphere trade winds. Can say it is a convergence zone. These trade winds will converge in certain places. Okay, because in the summer seasons it will go in the Indian region, and in the winter period it will go in the southern the equator southern hemisphere region. So this ITCZ, intertropical convergence zone, will play a major role in shifting this monsoon trough line. Okay. So. So when the monsoon is more active, okay. So when the monsoon is more active, That means the trough line, this dotted line is the normal monsoon trough region, monsoon trough line. So when this monsoon trough shifts towards southern part, okay. So what happened when the monsoon trough shifts? There is a maximum rainfall over this southern part of India, also this monsoon zone. So which is having heavy rainfall over this region. Okay. When the monsoon, this trough line, for example, if this trough line is fixed towards northern position, that is in the foothills of Himalayas. When this trough line is foothills of Himalayas, okay. Yeah. So this is the normal position of the trough line. If it shifts towards Himalayas, Himalayan region, the maximum rainfall occurs in the foothills of Himalayan region and northeastern region. Because on the other side, the entire Indian land region is very dry. So then there is a dry conditions in the entire Indian region. Okay. So because of this movement of monsoon trough, it is associated with the intertropical convergence zone. So you can also during the break period you can find this lot of floods occurring in the northeastern Bangladesh, because when there is a more rainfall in the Himalayas region, the all melted water will come into the Ganges, and it will lead to the flood situations over this northeastern part. So this is a one typical examples of monsoon break. You can see it is a 2002 monsoon. The left, that y-axis is rainfall in millimeter per day, and the x-axis is time in days. The black vertical line is actual rainfall occurring in 2002. It is starting from May 11th to 30th September. So the bottom panel is 2003 and our top panel is 2002. You can see almost 1 month there is a drought type situation. So again here the red line is normal monsoon rainfall. Okay, so there is a big gap in the rainfall because farmers required July month is very crucial, and it is also having the highest rainfall received in the month of July, and it is very important for the agricultural if the farmers knows the coming monsoon is drought, then they can change the crop which is having required less rainfall. Okay, if it is a flood, so they can change accordingly. They can choose the crop. The government and other like water management or reservoir water management, everything they will take appropriate steps once the monsoon forecast is known to us. Okay. And it is 2003. You can see this is a good rainfall. It is a normal rainfall here, and you can see all in the June it is good rainfall except a few days is a break. So this is a monsoon break, which is affect the seasonal rainfall. So 2002 is 23% deficit rainfall as compared to other the long-term mean. So now coming to what are these major dominant features of these large-scale climate drivers? So there are a few climate drivers like El Nino Southern Oscillations, that is El Nino and La Nina, that Indian Ocean Dipole, Madden-Julian Oscillations, Erosion Snow Cover, Pacific Decadal Oscillations, and other Arctic oscillations. So these are the large-scale drivers which influence the Indian summer months. Maybe you can have some doubt how El Nino, La Nina impact our monsoon systems, because generally El Nino, La Nina occurs in the Pacific Ocean. Okay, so now just we will, if the time permits, we can go for we can detail all. So otherwise, I will explain a few large scale drivers here. So if you can see this before going to this book, you can see this is the interannual variability. Interannual variability means during the monsoon season, that is June to September, what is the rainfall variation? Okay, so as mentioned that 2002 is very drought year. It is less than 23%. You can see here, this is that 2002. It is very severe drought, and some years it is very flood type situation. Okay, so it is year to year. It is varying rainfall. You can see here there are different colors are there. Okay, so the blue circle indicates La Nina years. Okay, and the red circle indicates El Nino years. So the red line is the dry monsoon, and the blue line is wet monsoon. That is surplus years and excess years and deficit year. Excess year means the good rainfall. It is more than 10% above the normal rainfall. And red line below this 10 is 10%, more than 10% below normal rainfall. Okay, so under now between these color, it is a normal rain. If you can see here, if you can observe this one, wherever the blue line is there, there is a wet condition over the Indian region. You can see most of the blue circles indicate La Nina years. Whenever there is a La Nina year, there is a good rainfall. Wherever there is a El Nino condition, there is a bad monsoon, that is less rainfall. You can see, for example, 2002 is La Nina condition, and you can have bad monsoon. Okay, so and some years it is blue circle and good monsoon. So you can know broadly, whenever there is a La Nina condition or El Nino condition, you can have some idea of Indian summer monsoon, whether it is good rainfall or it is a bad rainfall, that is less rainfall. Okay, so but for example, if you can see, there are some years, for example, 1990. Hello.
Yes, sir.
Can I share again? Is it clear? Hello?
Yes, it is.
Can you visual my slides? Okay. So there are some, for example, 1997, there is a strong El Nino year, but Indian monsoon is normal. And similarly, there is La Nina year, is also normal condition. That means sometimes this La Nino and El Nino will not work for the Indian monsoon. Okay, so we'll discuss these things, why it is. Okay, so generally you all know that the El Nino refers to the above average sea surface temperature that is in the central equatorial Pacific, that is 5 degrees north to 5 degrees south. Okay, so these El Nino conditions will periodically develop, and it will sometimes it will be above average sea surface temperature, that we can call it as El Nino. Okay, it is generally a warm phase of ENSO cycle. Okay, ENSO means El Nino southern oscillation. So this is a warm phase of ENSO cycle. Okay, so and La Nina it is the opposite condition. It refers periodic cooling of sea surface temperatures across central equatorial Pacific. And it also we can refer to cold phase of ENSO cycle. El Nino is the warm phase of ENSO cycle, and La Nina is cold phase of ENSO cycle. Okay, so this is a typical examples of El Nino and La Nina. Left panel, if you can see, there is a strong sea surface temperature. Okay, it is more than 29 to 30 degrees. Okay, whereas if you can see in the right panel, it is almost 23 degrees. If you can see the difference, anomaly, if you can see the anomaly from the last 30 years anomaly, you can see there is a 3 degrees warmer than normal. Okay, this type of conditions we can call it as El Nino conditions. If it is cold anomaly, that is minus 3 degrees, okay, minus 2 degrees. So this is a La Nina condition. So this type of conditions, how monsoon will impact and how, because India is somewhere in the region, and how this western Pacific Ocean impact our Indian Ocean. Okay, this we can call it as teleconnections. Okay, there is some circulation changes in the ocean, and also these ocean circulations will lead to the atmospheric circulations. Okay. So how it will impact on Indian monsoon, you can see here. So when you talk about this El Nino, so this is the 5 degree north to 5 degrees south over the central Pacific Ocean. Then this belt, we can divide it into 5 parts. One is Nino 1+1, that is this upper part, and Nino 2, and the yellow color is Nino 3, and the blue is Nino 4. Between Nino 4 and Nino 3, okay, this region is more impact on summer monsoons. After this, many findings, researchers found that this Nino 3, for this region temperature is more influencing for the Indian monsoon rainfall. So this is again Nino 3 index, how it will become. This is okay. So when there is a normal conditions, just as I mentioned that this is that trade winds, the southern hemisphere, the winds are blowing from southeast, and from the northern hemisphere it is coming from northeast direction. So this is the equator line. So generally, during the normal monsoon conditions, there is a warm regions over the Indonesian region. You can see the bottom picture. Okay, so during the normal conditions, neutral conditions, there is a warm conditions over the Indonesian region. Okay, when there is a warm conditions, what happens? There is a more moisture evaporation takes place over these regions, and it will have the circulation pattern. Okay, so this type of circulations, we can call it as east-west circulations or Walker circulation. So Walker is one of first our Director General of Meteorology, Gilbert Walker. He found this type of circulations in early 19th centuries, the 1900s. So that type, he started the prediction of seasonal forecast based on this ENSO condition. Okay, so when during the La Nina conditions, what happened? La Nina and the total conditions is more or like similar. During the La Nina conditions, there is a strong water circulation. Okay, and all the moisture take place and sinking. Okay, then the circulation will be takes place over the Indian region. So this type of circulations, it will enhance the low-level equatorial, low-level southwesterly flow from Arabian Sea to Indian region, and it will have a strong moisture flow over the landmass and have a good rainfall during the La Nina conditions. That is the one aspect. In the opposite direction, what happens? The strong winds will shift towards Peru coast. This is the Peru coast, and here there is a strong rising motion for during this Peru coast, and the circulation sinking motion is here. So then, in this case, the water circulation will be reversed or weakened during the El Nino condition. Because of this weak water circulation during the El Nino condition, then there is a less moisture transport over the Indian regions, and hence the rainfall over the monsoon region is very less or deficit. So this is the general phenomena of during the El Nino conditions. Okay, so this is generally the impact. So when you are talking about this La Nina El Nino impact, so during this El Nino condition, El Nino and rainfall condition, the top panel, if you can see, there is a dry in the Indian regions during the June to September season. Whereas in the October, December, during El Nino period, there is a wet conditions in the southern hemisphere. Generally, if you can see, if it is El Nino conditions, the winter, there is a wet conditions over the southern part of Indian region. In La Nina conditions, the whole Indian region is wet during June to September. Whereas the dry condition in October to December. So if there is a La Nina condition, the winter period is more dry. Whereas in the El Nino conditions, it is wet conditions. So these are the daily connection for prediction of Indian summer monsoon. So IMD, it is one of the parameters to do the statistical prediction for monsoon season. Is one of the El Nino condition. Okay. So now let us see what's the ENSO prediction. How the coming monsoon. Now it is April. This is the weekly average of 2nd April. You can see there is a cold anomaly, right? So the cold anomaly of sea surface temperature. That means it is neutral to, it is going to La Nina phase. If you can see these 3 phases, this is already discussed that regions, right? So if you can see the area average sea surface temperature, 1+2, 3 and 3.4, because we are more concerned about 3.4. If you can see here, this is the May 20th, this is the April, this is the 24th, and from August onwards, 2024 August onwards, there is a neutral conditions, and it is January, it is El Nino, and again it is going to be neutral conditions. So you know that there is a ENSO is the neutral phase. That means the coming monsoon season is coming from normal monsoon. You can say it is a normal monsoon, right? So this is one type of prediction. If you can have the knowledge of data about ENSO condition, you can predict the coming monsoon is going to be a normal monsoon in India. That is 2025 monsoon season is the normal monsoon season. Okay. So if you can see this, there are a number of models in the world, the dynamical model, which is using this differential equations based on atmospheric governing the finite equations and predict the atmospheric phenomena. And another is data-based statistical models. You can see this that dynamical models and the statistical models. You can see there are some models is giving higher temperature, some models are giving lower temperature. Then if you can see this ensemble prediction, okay, that red line is the dynamical prediction models, and the green is statistical prediction. You can see all the models. This is from December to January.
Am I audible?
Yes.
Yeah, please conclude within 10 minutes.
Yeah, 10 minutes. So all these predictions, it will lead to the below 0 degree, below 0 degrees. That means this is average neutral conditions. Okay, so this is type of prediction. If you know, then we can have that monsoon is to be a normal monsoon. Okay, this is again, this is, you can see here monsoon. The blue one is the La Nina year and red one is the El Nino year. The coming seasons like May, June, July, August, it is all neutral is dominating. Okay, so based on this ENSO forecast, we can conclude that the monsoon 2025 will be a normal monsoon. Okay. But other factors like Indian Ocean dipole, as I mentioned, that Maiden-Julian oscillation, it will also impact on monsoon. Okay, so generally Indian Ocean dipole is it is also like ENSO-like phenomena, but it occurs in Indian Ocean. Okay, there are two phases. One is a positive phase, and another one is the negative phase. So positive phase means that warm SST anomalies over Western Indian Ocean and cold SST anomalies for Eastern Indian Ocean. Whereas in the negative Indian Ocean dipole, cold SST occurs in the western part and warm SST for eastern part. That is equatorial Indian Ocean. So this is a typical example of positive dipole mode and this one. This is how the winds are dynamics of positive IOD because Arabian Sea is more stronger and more evaporation takes place over the Western Indian Ocean and apart and with the support of cross-sectorial flow, the moisture will transport to Indian landmass and gets precipitation over Indian region if it is positive IOD. So as I mentioned that in 1997 there is a El Nino condition, but India is having the positive IOD. So it will surplus that ENSO conditions and dominating the Indian Ocean dipole event. So this is the circulation phenomena of positive phase of Indian Ocean phase. And the negative dipole mode is again the cold episode is over the Western Indian Ocean and warm is in the Eastern Indian Ocean, and the circulation will be the opposite direction. So when it is cold, the evaporation is less evaporation and less moisture transport over the Indian region, and hence less precipitation over the Indian region. This is again the circulation will be reversed, more enhanced over the eastern part of Indian region and the sinking motion over western part of Indian region. So this is one of the examples, as I mentioned, that 2002-2003. The top panel we can see there is a cold SST, outgoing radiation. Positive means it is more less cooling and it is more warming. You can see there is a negative IOD in 2022. Because of this negative IOD, you can see the big drought in the 2002 year. Whereas in the 2023, July, this is the July month, July 2023, there is a positive IOD. It's more warming, more Western Indian Ocean and cooling more the Eastern Indian Ocean. Then this positive IOD leads to good rainfall over the Indian western part of Indian region, as well as cooling over the eastern part of Indian region. This type of critical conditions, so it will minimize this ENSO phenomena, and it will positive IOD, which will take a lead, and it will the monsoon will become normal or good rainfall. So this is again current IOD index. If you can see this May 2025, this is April. This is up to April. This is observational data for the IOD index. IOD index means it is the subtraction between the positive. You can see here there is more positive for the IOD index. That means the coming monsoon will be like positive IOD with a La Nina condition. That leads to normal or above normal. We can expect normal, above normal rainfall for Indian region. So, shall I continue or shall I stop here?
2 minutes more, I think.
Okay. So I will go very briefly that maiden Julian oscillations. What is the maiden Julian oscillations? So, so maiden Julian oscillation, it is a progression of large regions with enhanced and suppressed tropical rainfall when it moves to west to east, mainly over the Indian or Pacific Ocean. Okay. So because maiden Julian oscillations, it is actually this oscillation leads to 30 to 60-day oscillations. It will have some generally it is 8 phases, each of 1 week each. That's each. Because of this maiden Julian oscillations, you can see the intra-seasonal oscillations. Intra-seasonal means variations within the season, like that is June to September. Okay, so this maiden Julian oscillation is a eastward tropical propagation of waves, which leads to enhanced subsurface precipitation for Indian regions. So generally, this maiden Julian oscillations, this type of oscillations identified by the 2 researchers, maiden and Julian. Okay, so the name has come from maiden Julian oscillations. Okay, so these oscillations, it will start from Indian Ocean and travels up to 800 kilometers in this. Okay, so this is Indian Ocean SST, more enhanced convection over the Indian Ocean, and it will. This is a day 1, day 10. This is a typical example day 20. So it will move. Then the cycle will be repeated. So that's what it's called 30 to 60-day oscillations. It will vary from 30 days to 60 days. So this is how we can measure the maiden Julian oscillation. We can measure it with the one of the parametrical outgoing long wave radiation, zonal wind, okay, velocity potential. So there are some parameters. Zonal wind means it is east-west direction of the wind. So how it will influence this maiden Julian oscillation? The intensity of monsoon system will influence wherever these oscillations will travel, and it will enhance the tropical rainfall that leads to severe floods, and also these maiden Julian oscillations also enhance the tropical cyclone activities and also impact on ensocycles. So this is one typical example in the outgoing long wave radiation. You can see here there is enhanced activities here. You can see here. So you can see here this will change the activities, right? So it will, whenever this maiden Julian oscillations shift from May to September, you can see the left hand panel, it will shift from east to west. So whenever when this moving, there is a rainfall activities over this region. So what are major regions impacting the region is this, the blue color, particularly over the Indian region. It will modulate the monsoon system. That means it will enhance the precipitation over the Indian region. Okay, and also it will influence the tropical cyclone activities, which leads to impact the rainfall over Indian. And also this wet and dry conditions in the tropical region. Yeah. So thank you very much. And if you have any queries, then just quickly.
Thank you very much, Professor Rajuji. I mean, this your talk is completely relevant to. Actually, you can say it is. I have one project from SERPS your DST. So I can say this is very helpful for my JRF candidate and for me also. Even it will be helpful to other students. Those are basically looking for PhD or career in NWP and monsoon. So in last 4 or 5 talks, I can say that the participants must be looking how we can get the real applications of applied mathematics.
Yeah. So basically, from last few days, we are more depending on the developing the model, what is the monsoon forecast in data estimation. So I thought I will give a brief introduction about the monsoon system. So how the monsoon system, what is the basic mechanism, and what are the large scale drivers which influence the monsoon. Once you know these information, when you construct the modeling, it will be for your.
Thank you very much, sir.
Any queries from the participants?
They can mail to me or sir.
Yeah, you can mail because of the time constraint.
Mr. Raju also have one project. So he has advertised JRF positions in his project. I can share you on your WhatsApp group. If anybody interested, they can apply for their position.
Yeah, we have 2 positions are there.
He is basically our senior from IIT Delhi. He is a thorough researcher and very nice person. And he is a very, knowledge on this India summer monsoon. Thank you very much, sir.
Thank you.
Valuable time for this FDP program. I can say our FDP program is 100% successful because we have at least have a good number of speakers from different areas. We all have given a valuable time to this FDP. Thank you so much, sir.
Thank you, sir. Well, signing off.
Now, the next talk and the last of this FDP is Dr. A.P. Singh. He is an expert in seismic theory basically. Now this is entirely different perspective now. Even you can find a lot of application of mathematics in earthquake basically. Everyone knows about the impact of earthquake, how is it devastation for the life and the recently there is an earthquake in some country, I forget, I think Philippines. Yeah. Now he will give you the some idea about the seismic theory. Is anybody interested to make a career or application of mathematics in this field? She can listen this talk. That will be very much helpful. And this is the final talk. That will be after that followed by the valedictory. We will start at 4 o'clock. So I request Dr. A.P. Singh, please start your talk. And the Dr. A.P. Singh, basically MSc Tech from Banaras Hindu University, and he did PhD from Kshetra University. He is a senior scientist in Ministry of Earth Science, and he has a very good number of publications, more than 100 publications, and he is a very good writer of manuscripts and papers. He has a papers in very highly impact factor journals of his field. You will see, and he's a very down-to-earth person, and he was basically, when I was doing PhD in IIT Delhi, we have some time, 3-4 years in IIT Delhi, when he joined as a scientist B in Gujarat. And now he has shifted to MOES the last more than 3-4 years as a scientist B. So I request Dr. A.P. Singh for the talk. Dr. A.P. Singh.
afternoon and namaskar. Thank you very much for giving this opportunity to speak on this platform. I'm this is Rajesh, earthquake engineer. Okay. Here I would like to talk about the specific emergency during I will say here about some application. What is the application? How is seismic emergency important? Why the seismic emergency is important to delineate the structure, delineate the parameters. Some other tricks in magnitude 5.9. Okay, I about 38,000 people using this and it's so many people were homeless and cost of the system was 150. Okay, and intensity was maximum. Okay, another earthquake is the Kobe, China earthquake, and magnitude was 7.2 and it occurred in 1995. About 1,200 people were dead. And even Kobe express was hit. It was the second largest earthquake in the world, and the magnitude was 9.6 and about 3 lakh people were dead in the earthquake. It's not a earthquake, and the Asian earthquake not due to this earthquake. Because analysis of earthquake and analysis of tsunami. 5 meter deep earthquake, and this is about 2 lakh and even your whole earth oscillation starts during magnitude was 9. First magnitude was maximum 9.6 happened in 1960 and even the water has was 50 meter at the source and that was and this is one earthquake the intraplate earthquake because occurring within the plate and it occurred the April January 2001 economic losses within $5. Another aspect when you live in a and this is poor country. Earthquake are emptying the 2 to 3 lakh and the earthquake is happening and in 2010 when it was Professor Peter Gorman all the man-made like war, genocide, vertical, stratification, and he found about 1,100 billion deaths. And what is vertical? You can say these are the not natural disasters, these are the man-made disasters because after this cannot only settlement like climatic structures are so we construct the building according to the zone, according to the engineering process. So we are in the basically National Center for Seismology is a nodal agency of the government of India, and the main vision is minimize and vision is to understand the earthquake in the different parameters like hazard, seismological. So what are the components at the NCS? So basically, what is the we are giving the information. is the main work is the dissemination the information within minutes. If you have any earthquake occurs for any reason. Okay. And secondly, maintenance the specialized data center and information, providing the safety factor. Because I told you, the earthquake does not see the all casualties happening with the collapse of building, collapse of bridge, etc. Then before the construction the building, you should take the advice from the engineering, take advice from the geoscientists, how to construct the building, parameter you should get up to construct the building. Because casualties are happening because I saw so many pictures. Picture of a heavy at very poor country, so the magnitude was 7.1, but casualties were 250 lakhs. Why? Because they have poor country, they cannot do the proper construction, make the proper as of engineering prospect. Okay, so that's why you should do we are doing the safety factor of the building so that it can construct the building, it can be less susceptible to damage to the earth. And secondly, the public awareness of earth science education and understanding the earthquake and you see so many parameters and so many departments in the NCS. One is the National Technological Network. We have 166 stations across the country, and that connectivity at the center between stations, and we can locate within minutes what has been we have a mandate to give the information to 100. But we can get the information even if you have an earthquake still like 10,000 kilometers away from the center. So we can also detect the any earthquake to happen in the America upon land. Another is the seismic risk assessment. So we are doing the risk now. If you have a know the risk is very the maximum risk level, then you can understand very that is the seismic hazard. Another is the borehole geophysical insight. So this is located in the Karad, Koina, Maharashtra. Okay, so what they are doing, they are actually cannot bring the power because whatever information of the earth we are getting by the to wave farm. If you have any application common people are up there, oh, earthquake is there, but you will have because earthquake is a lot of information. So, okay, to the emergent process and get the process, what is the different. So here, both of the official research there we try to drill the earth to the maximum we are going to drill the earth 7 kilometers. We have already drilled the 6 kilometers. What is the importance of this drilling? The importance to understand this area of drilling there has been a very shallow depth, 7 kilometers, to give the information why the earthquakes are occurring there, because there are earthquakes are happening. So there the things are making the very deep, but to point out earthquakes 7 kilometers, that's why you try to understand the drilling to understand what is inside the earth, what is the first, because whatever you are taking the information in one process is a mathematical modeling. But here we try to borehole the data and actually the earthquake research process doing the earthquake also to do the waveform emergency and the waveform and these are what is the cause of the earthquake. The National Technological Network. So you see, we are 2014. Actually, we have 120 but such technological activity installed in 1897 after the Sri Lanka earthquake in 1987, and such technological activity in 1898 because that installed after the Sri Lanka earthquake in 1897. That's magnitude was 8.7. Earthquake had actually the future of which here in the so we have a total all the connected with the display, and if you look at the station of the okay, and this is connected to the display, and data receiving at the CR center at the India and we should be located because this is a 24/7 information we are keeping this information. These are the systematic of technological operations, how we are doing this operations. These are the structure. You see, these are the different components, how we install the technological station, and these systems are connected to the switches, some were connected with the internet, and we are doing the analysis and dissemination of the information to different media like this. Mobile apps, and other another apps also. You can also install that. That's called the Pump app. And install, you can get information. It is not have any update from it. These are the output. That is the monitoring capability. How we detected, so I told you that first installed in 1898, that's why we have nearly 120 years history of the seismological station in the front, the first seismological station. At that time, we can detect only 5 magnitude and error. We cannot detect any earthquake because the station is not very high. Then slowly what station, and then we can detect magnitude 3. That magnitude can give the information. This is likely to have any area. Then we can also get that. Okay. And these are the operation capabilities. These are the output if you have any earthquake. So these are the focal mechanism. Focal mechanism means the shape of the part. That's of part generated earthquake. And these are the intensity. You have to see intensity whether your area is affected or not during this automatically. So we have a software, automatic software that keeps the information within station. But before dissemination has to be earthquake, and for sometimes software some information, and that cannot be diverted. And these are the information how we are getting and how we are disseminating. We are disseminating the information of images and government authority where the happens. Yeah. Okay. Why monitoring is important? Monitoring is important to giving the peak. That is the important. Why? Because you cannot predict the earthquake. You cannot say you need advance even earthquake coming. Like meteorological parameters, you can say the cyclone, when cyclone is coming, what is the monsoon activity in the next season. But you cannot say about the earthquake because it requires a lot of mathematical modeling required and a lot of research is required to understand the earthquake phenomena. This is not the key. Okay, so that's why we are doing the monitoring, because this is the information within minutes, that is very important for okay. But we did the technological ability in Geelong, 1898, first December 1898, that the Geelong observation was installed and it was operated by students. And these are the seismological equipment. So in each station we have a broadband seismometer at the base is the velocity. Okay. And you have an accelerometer that gives the acceleration. It is very important for the engineering software. It is important for the building speed. And we have a decider. And we have another software that's called SysCom3 that gives the information immediately within seconds. Okay. If you have any earthquake. It's a typical specification. We have the pillar. We install this specification at the pillar so that we can minimize any noise nearby. Okay. So that we can detect any noise generated by motherland. We got the typical example of the food station, and this is the part of NCS. So these are specification. We have some seismological are there, and they are doing the analysis of the data, and then we got the research and solar panel and getting the information here. We got the instrument. We got specific project. The data we can get from our website just to see where you are placed. You know, here is plotted only up to 2005. So 5 is fake and change it to we have mandate to have any information within this area, we should keep the information. Okay, if you have any earthquake reference, then you can give the information of anywhere in the world, and these are the seismicity. So you see the most seismicity where located is the Himalaya and Andaman Nicobar region, but some intraplate like Gujarat, you see the Kutch region where so many earthquakes are happening. so many earthquakes are happened. In the year of 192, there were two major earthquakes. One was the 8 magnitude. That earthquake generated meter height and nearly 100 kilometers peak created within India and Pakistan. The Muslim community was there that can call Allah one, it's of Allah. That's the Allah one. And another is 7.72 that place. This seismic zone in map of India. You see, whole zone is divided into four. As again, zone 2 is a where you can get the maximum intensity. Okay, and maximum zone was the antenna zone is the 5, 50 the great price in the Himalaya and the North India, Andaman Nicobar, and in the India, in the first region where the test is 5, and then we can expect the magnitude 8. Okay, and Richard area is zone 2, where you can expect the maximum intensity 6. So what is the cause of this earthquake? Why these earthquakes are occurring within the India and the boundaries? The main cause is because of the movement of Indian states towards the Eurasian plate. Okay, so you see that it is the sixth measurement, the global position system and that. Your Indian plate is moving towards the north and colliding along the Himalaya, okay, with the Eurasian plate, and that's why your Himalaya is 8.4 kilometers and their activity is maximum for so many places generating at the Himalaya, along the Himalaya, and another is Indo-Burma. And due to this space, some states are generating the plate, meaning between the plate, which is away from the 200 kilometers away from the Himalaya and 1,000 kilometers make up Macron fault, and that generates out to some earthquake in the earth. Okay, these are the earthquakes. You plotted all the earthquakes to see where you are there. Most cases you see the whole India is seismically affected. Here the seismicity is range taken from the greater than or equal to 3. So you see most seismicity are concentrated again in the Himalaya and in the Andaman Nicobar and some earthquakes within the plate and in the southern part of India. This is the Bhukamp app. You can install in your mobile and you can get the information in earthquake, any earthquake. This is the Great Sumatra earthquake. So these are the waveform, and that waveform gives a lot of information. Okay, and for that you need to do some mathematical modeling like inversion. Inversion, if you do the inversion, you can get many information. You can get the information what requires what the crack density and what the accuracy and the specific velocity and all. So these earthquakes are recorded at our historical network, and these are the stations, these are the parameters we are taking up for the inversion. So whatever we are doing, we are doing some mathematical. Without mathematical modeling, we cannot do and cannot get this information because we have the waveform, and from this waveform you have to apply the different model to get the earthquake parameter. And that earthquake parameter means it has a coordinate, latitude, longitude, from where it is originated from the earth, and what is the magnitude, the origin time. So what is the seismic inversion? Is the topic here. Seismic inversion is nothing. You see, whatever you are getting, extracting the information from the waveform, that is the. Okay, so there are the two parties there. Forward modeling, you know, and then it's the inverse modeling. So inversion here we talk about the inverse modeling. Forward modeling means you have a model and it gets the data that is forward modeling. But if you have a data and get a model that is inverted, so here we are doing the inversion from data, and from that data we have to generate a model, and from that model we are generating. So because this seismic inversion basically used as the alpha. So in this requiring natural gas corporation, we are using the to get the oil, gas, natural figure beneath the earth. Okay, you can get the information of the mineral because yes, I the information. Here at the earthquake and we are doing the inversion to understand the structure, structure, what is the structure behind that. So this is the inverse modeling, and set. You see that this is the application of this seismic inversion. Understand the structural heterogeneity. What we are doing as a seismologist, earthquake engineer, what we can understand is where is your high velocity well, low velocity well, is acquired. That can be the inversion. Whatever I have heard is that data is converted into model, and model is your information. Reservoir characterization, that ONGC oil natural gas application is doing to this seismic inversion. Everywhere you have a mathematical model. Without mathematical model, you cannot extract, you cannot put the postmortem of the wave form. All information we are getting from this form. So these are the programs. Okay, so if you see the programs coming from the art, you see a lot of information. So many pages is there, and each page is information between the art. Okay, so some pages is coming from the art, some pages coming from the center. You can stand delineate of 1,900 kilometers. And put it in what I call. We are the seismic part. Seismic part is nothing. This is the seismic zone, propagation part, kilometer, and some noise is there. Okay, so part of the seismic on this to the different message you can get all the parameters. What is this? Then you can delineate. So, what information can seismic inversion give? So I told you that if you have a data and give the model, that is but if you have a model, you try to get the data that is modeled. Physically, we are doing the inversion in different sources that is one model. What information getting from this waveform, that is the efficient that is called the efficient. How far from the earthquake magnitude? What is the magnitude? Magnitude is nothing. How much energy is released during the earthquake? Suppose earthquake is not coming, what will happen? Whole earth will be hot. Whole earth is hot because earthquake is nothing. Release the energy. Okay, and someone is the intensity. Intensity is the damage degree of taking part by the earthquake. So they are the two effects. And intensity. Earthquake is there. Where is from where? What is the source of the earthquake? The maximum depth is 700 kilometers. It's coming from the maybe an if you take the Gujarat region, there the maximum depth is 30 kilometers. If you take the Himalayas, 40-50 kilometers, like that. But somewhere the shallow earthquake is coming at 7 kilometers. And earthquake mechanism, from earthquake mechanism you can understand what type of fault and nature of earthquake. What's the nature of the fault? What is the nature of the fault? And propagation part, how propagating the fault in the report and that's what it is. Implemental response, noise level, and this is graph sensitivity and cycle response. That is all we are getting to the waveform. Okay. Without math, we cannot give this information. This is the earthquake that recorded the analog seismograph that 1956 Anjara earthquake magnitude was 6.0. Okay. And this recorded the Delhi station and earthquake in Anjara in the Gujarat. Do you see? Just to see the waveform, you can understand whether it's coming from the local or coming from the distance. This is the earthquake occurring in magnitude 8.0. And after 12 September 2007, and distance was about 5 kilometers. So this is to have a lot of waveforms, that a lot of information given from the system and from the beneath the earth. Because a lot of waveform you can make it valley and so many ways of the propagation of wave. And this is a local earthquake connected between the I think 88 kilometers with the fiber. So waveform you can understand whether it's coming from the long distance or coming from the local distance. If you have a local distance, you can get very parallel information. But if you have a long distance, you get deeper information because the why? Because this contains the low frequency. If you have a low frequency, that will give the deeper information. In the earthquake, in the recorded, whenever earthquakes in the evening, we are doing the 24/7 duty, that we are centrally this at the village, and that's part of the military apartment. So we are doing this service. on any time to get the information about the earth. This earthquake was 4.25 and 611.55 km, but after that we are doing the inversion to get the information. From inversion we are doing the automatically, and after that we are reviewing to get the precise information. Like you see, the Pakistan earthquake and 2013 this magnitude was coming from the Pakistan, because there are no political homes that are set in place and for people in there. And then Stan earthquake 6.8, this magnitude was 6.8. So how we are getting, so through inversion we are getting the different information. So first inversion we done for the earthquake tomography. So tomography is nothing, it is the X-ray of the earth. Okay, so whatever you are taking the X-ray in the hospital or the human body, whatever we are getting the how density is affected inside of the earth. Similarly, we are doing the density X-ray of the motherland. As we are the doctor, but we are the complicated because our facility is not forward. So many complications is there, is not easy to take the X-ray, but Happy and 1970, this is the first inversion of the earthquake tomography, and the mathematics of modern day those mathematicians, and they did the earthquake tomography body weight, because like the X-ray, surface weight, and the clock weight, these are the weight form they have taken to the tomography. So this is specific weight and specific structure, how we are looking, and structure is there, mental information we are getting from this wave function. Just example, I am taking to the Gujarat region, you see so many specifications are installed there, you see all the government of Gujarat, and so many stations are there, and so many events in the Kutch region, and that's recorded at this station, in the tomography of the region. So tomography is nothing, it is the X-ray of the motherland, and that X-ray is the how heterogeneity is, where is the high velocity, where is the low velocity, what is the cause of it, why so many earthquakes are happening, so many different causes, and we can get that will give a lot of information. Carrying so many information and these are the one layer of the model, and that will take the before doing the tomography, whether your X-ray is good or not, that we need to take different ways. Either take a boat phase, cat night phase, and so if you take a boat phase, you need to have it low and high velocity for getting by the inversion. So many parameters we have that. You are taking this type of picture, can say, or X-ray. So on the basis, so how can you take the reliability? Whatever you are doing at physical body, you have to take the observed data. Whether you have a zero, it means you have exactly match the observed and calculated, that is also wrong, because you cannot because so many errors are there in the parameters, including the errors in the instrument. So many errors are there. You have so many variations there that you are not also. So you see, on the basis of that, you can say somewhere in the regulation is bad. Okay. We have both locations to the inversion, because initial location and after inversion we have the location like that. So many earthquake is there, and it will not actually happen in the activity, it is actually good. So after the inversion you are getting the current value, and you can say our earthquake velocity happening of kilometer maximum, very good. More is the nothing is the thrust and mental boundary. So I think coming from the lower side. We have another stage that we are doing the synthetic, and we have the tomograms using the X-ray of the motherland in the Gujarat. This is our top section. So from to paperwork, we try to understand the size of the how they want what happened. When people were seeing the Gujarat, what is happening, because it is 400 kilometers from the Himalaya to 1,000 kilometers. What is the cause of there? So from here, those data sets is getting version with the data set, and we are taking it at a depth of 25 kilometers. They are the low velocity zone. What is the cause of low velocity zone? Why the CP is low, here is low, and another parameter is called the quality rate. That's the CP by here. Why is the high? So what is the reason is that on the basis of that, can say the rock property up there is the Q there. Q is there. That's 25 kilometers. So people will ask what is the cause of the Q? Why is the Q is there? Because there is a tendency of rock, crystallization of rock. We have not some synthesis of Q. So many things will happen. That is the parameter like CP by of that, given that 2001 earthquake was a boom, was a huge earthquake. What happened at the depth of this? And it cannot rupture at the depth of a substance. It is not any meter. It was 1.7, but similar earthquake happened in 1889 in the and was hit, and immediately 100 kilometers apart, 100 kilometers from and I was 6 kilometers at the same quality of India and Pakistan, and not Pakistan, but they are the Muslims community, the group to Allah, of Allah, and that's why that region is called the Allah. So these types of activities are happening due to the earthquake, sometimes rupture, sometimes ruptures are related to the earth. So many possibilities behind that. At least the body, we can understand the behavior of rock, behavior of properties of the rock. This is the visual we are getting high to see here, electricity happening like so here. Another so this inversion, you can understand the behavior of parts. So many variation on some people are saying someone saying the south-facing part. What is it exactly? If you have a north-facing part, then the north-facing will affect much because the force of direction is the energy of direction. If you have a south-facing, then a south-facing will affect. What is exactly because the length of the KMF was 100 kilometers. So to the earthquake tomography to be specific inversion, we try to understand and finally we accepted that the KMF is not parameter tomography. So actually what I want to tell you is that if you have a mathematics and if you have a mathematical model, all that you can order it to the set of equation. So all the based on the mathematics. If you have the mathematics, then you can eliminate any instruction on the big form structure, and that is you can eliminate. You are doing so many mathematical models with the tertiary sciences, but they can able to predict precisely what is that. That is also the mathematics. We are also the mathematics. We are doing a model of the data. If you have a model and you are trying to get the data, that is called the forward modeling. I told you now, you are talking to me. Okay. Okay. And second one is the monsoon induced electricity to moderate earthquake. What is the monsoon induced electricity? That we try to understand. What happens in the Saurashtra, in the Gujarat, Saurashtra? What happens when the maximum income is there? There's a magnitude is 5 times expected. What is the cause? Whether it's a monsoon can generate earthquake? What is the cause behind that? Okay, so there's a sometimes there's a rainfall, so can see that. Okay, so what about the 2007 the magnitude was 4.9, 1%. And another in 2011 there another rainfall is there and their magnitude was 5.9. So what is the cause? Why is it happening to this rainfall? Whether rainfall can generate the monsoon earthquake? So finally we are doing again the inversion. We are doing a mathematical model. The data, whatever data we started, we are getting that the cracks and fractures are there. And whenever the rainfall is there, the rainfall calculates the fracture and due to the force pressure, the force pressure generates a small earthquake here. And there's a 593, it generates this stuff, calculating the water and it generates the force collapse. So the phosphorescence is happening and the earthquake is generated. So that also we got to the mathematical model. Do you see polar magnetic? So we are using your equation to choose the different parameters, and we have the different parameters called the porosity, and so many parameters we are taking. Okay. Again you see the some examples of the Karnataka region. Okay, so what happened? I think 2 months before, there was an earthquake, and magnitude was like 3 magnitude. 3 magnitude and not 6 there is not much 6. Okay. So what happened? The 3 magnitude is there, but creating a lot of noise. It's creating noise like a explosion. Okay, like a song. So what is the cause of that? Why we are hearing this earthquake noise during the generation of earthquake? Even magnitude 0.2, that we cannot hear. Okay, but we can make a lot of noise. What is the cause? So we again use this digital modeling, and we are taking if people have a frequency range of 20 or 220K. Okay, even audio range. Okay, 20K. So if you have an audio range like that, so you can understand if the earthquake you can hear. So these are types of activities that happen in the Karnataka region, and maximum we can do what they say. It's very nice to watch with this, and it's not very harmful, but that can make the noise, and that can make the noise like a plastic. Can make noise like a pump. Okay, so what is the cause of that? Because we have a shallow earthquake, and then one infection in the area that makes the understanding of the earthquake in the area in the application very important and as well as the Karnataka. On this is the tomography sector of the NCR region. So many earthquakes are happening in the NCR region there. Okay, so we see the tomography in the region. So we are getting the high density zones where the maximum high density is the minus 60%. This is the perturbation. Where that's got a high density zone there. The low density. So whatever that is and that is called the high and low velocity. On the basis of that, we can see why the earthquakes are happening in the NCR nation sector, because there are complicating from and that will be energy, and that can trigger failure during the earthquake. So this is the earthquake in the earthquake magnitude 4 was happened. Have you read that? What? After 10 theater, 4 magnitude was. Yeah. Another is this is the Sri Lanka earthquake, and I told you we have specific first specification we saw in the Sri Lanka in 1896. After the Sri Lanka earthquake in 1897 earthquake was there, and after this earthquake we installed our specification in the Sri Lanka. In this way we have the 120 years history of the seismic monitoring in the country. But that time we have only one station, but we installed now we have one station, all connected with the station, and data is doing that. So what happens in this earthquake, we have the earthquake. Earthquake, the whole part is the feature of this down region. So that is called the pop-up tectonic. The pop-up happens, pop-up tectonic, and this is what 8.7. And these are types of mechanism are happening. So we try to do the X-ray of the motherland. X-ray of the motherland, and these are the again the you see the rate in this box there, and these are the rate you can see this high velocity function of the lower dimension, and that's why we have pop-up tectonic and this okay, we got the board. Okay. So finally, what I told you, I want to tell you, we have a specific manipulation, and that data can be utilized by the mathematical models to do the different information and value different parameters, and locate the earthquake to be emergency. Okay, so your mathematics is important, and it's because we are using the model only, and that model has so many non-linear equation, and that non-linear equation have developed and further solution, and we are getting this type of information from the earthquake data. So thank you very much. If you have any question, please.
Thank you so much, Dr. It was such a wonderful talk. Yes, is there any question from the audience? Okay, sir, I have one question. Sir, is there any method by which we can predict the
Answer is no. There's no any precursor study or no any simulation before the earthquake. What happened in the Gujarat government supported to keep the information before the earthquake. So we have installed different parameters like in negative value changing before the earthquake. Whether magnetic value is changing, area is changing, so many. So we have installed so many parameters in the Gujarat. But still we cannot get any simulation. Some countries they are getting the signature in one earthquake, but another earthquake is here. So if you have a that's the no technique. But what we can say, because I told you, the all casualties are happening due to the collapse of building. Okay, collapse of trees. So we should construct the building according to the engineering process, according to safety rules, and that is very important because the earthquake are not in the people. All casualties are happening to the man-made structure. So that's why the government has been doing the system microorganisation of the country, and they have already done the system microorganisation as I think 10 cities, and this system microorganisation finally will get the risk map. Where is the high risk, where is the low risk, the earthquake, and this kind of
Thank you so much, sir. Okay, let's join after 10 minutes for our validity function.
Thank you, Dr. A.P. Singh. Very nice talk. And now we will start our validity function after 10 minutes. Thank you for a valuable time.
Minutes.